All right, morning everybody. Glad everybody made it out this morning after the party last night. This is the best slot of the week. My name's Tom Moser. I'm a senior program manager on the Azure Information Protection team. And we're here to talk about extending sensitivity, labeling, and protection to your own apps and services with the Microsoft Information Protection SDK, which I think wins for the longest title of the week. So the agenda today, we'll talk about what exactly is the MIP SDK. We'll talk about some of our ISV partners. We'll cover SDK fundamentals, so how you can get started on your own. And then I'll do a couple demos that cover really our primary use cases between the File API and our policy and protection APIs. So before we get started, quick show of hands, nods, grunts. How many of you are actually developers in this room? All right, a few. So primarily C#, C++. One. That's the tie for last year. We got one. So the Microsoft Information Protection SDK was an effort we started almost 2 years ago to bring Azure Information Protection labeling, classification, labeling, and protection to our partner applications in a much easier way than we had in the past. So to meet that goal and to make it easier on us and easier on our partners, we built a cross-platform solution that works on all the platforms you see here. So Mac, we work on Debian, Ubuntu, Red Hat, CentOS, Linux, Mac OS, Android, iOS, with C++. And then we work on C# and Windows. We're looking at .NET Core for the future. And so the idea is that I can write one application on one platform and then with some minimal effort, make that application work across any platform using C++. So it enables us to broaden the reach of the Azure Information Protection and Microsoft Information Protection technologies in your organization. So a common ask from customers for our team has been, does vendor X integrate, and can they read your labels? Can they apply protection? Can they reason over your protected content? And the answer is absolutely. Just pick up the SDK and they can start to do that work today. The other thing that's in beta right now, and I'll show you a demo of this in a few minutes, is that we've begun to move some of this functionality from the SDK to Graph. So certain functionality works well for, as a REST endpoint, and it's a bit of work to integrate the SDK for some of those use cases. And so now we have the Graph endpoint in beta that I'll demonstrate here in a few minutes. So what's new? C#. So we've got the entire SDK works now in C#. We released support this week for our protection API, which we'll talk about in a few minutes, in C#. So you can use pretty much the entire SDK in C# and Windows today. We released a C-style API for protection and policy. We did this work because a lot of our partners required, they couldn't take our C++ native libraries directly. They needed a C wrapper, and so we gave them that. So the Edge support that I'll demonstrate in the next 40 minutes or so, it was built on that C API. And then a big one for us was support for MSG files, or specifically for email scenarios. And so a common scenario that we hear about is I need to decrypt a message to inspect it, or I need to maybe decrypt a message, apply a boilerplate signature, and then re-encrypt it and send it on its way. And so in this release, we've really focused on improving the MSG decryption experience. We've got an engineer who worked on this full time for about half of the quarter. And so now we can fully decrypt and encrypt MSG files. Now that doesn't include MIME-compliant messages, so if you have a need for MIME-compliant, like EML-type decryption, come talk to me afterwards, and I'd love to hear more about your use case. The other one is inspection of message.rpmsg files. So that's the actual encrypted part of an encrypted email. We allow you to inspect that and look at the plain text contents. We don't write it out to a file because it's not really useful to write that to a file. Previous updates, so we shipped these in the last 2 quarters or so. Our cache database was previously written in plain text on disk. If you opted to use the on-disk cache, we encrypt that now. So if somebody's browsing the file system, they can't look at your policies or any of the use licenses or anything anymore. It'll just be encrypted data. We've made various performance improvements around how we handle delegation, how many service calls we make and things. And then we release every quarter. So if you're working on the SDK, expect a quarterly release, usually the 15th after quarter end. So we delayed this one a little bit because we wanted to launch Ignite. The next one will be around January 15th or maybe a little later than that. Partner ecosystem. So we're pretty proud of this. We've made a ton of progress in getting our partners on board. So we've got Adobe, so you can now consume protected PDFs using Adobe Reader. We've got Palo Alto with their firewall solution, so they can inspect traffic in their next generation firewall, and if they see AIP labels or protected content, they can notify the admin or they can block that traffic entirely. Secure, I'll show you here in a minute. And then various other partners that we're working with. So if you have a partner that you'd like to see integrate with the MIP SDK, we really have two asks. One is tell them about it. There's nothing worse than somebody saying, hey, Microsoft, can you integrate with this? And we're like, we don't write their code. So we really need you to go to that partner and say, hey, we need this. We're your customer. Do this for us. And then we will talk to whoever we need to talk to make it happen. So we talk to quite a few partners every week. And that's mine and Kartik's job is to make sure that we're getting partners on board. One of the partners we highlighted this week was Secure. So they make various different technologies that they've built on RMS. One of them is their kind of initial stab at this was a product that would protect files coming out of SAP. So you could classify data in SAP, and then an export, they'll apply the label and protection to that data. So if somebody's clicking that export to CSV button, or export to Excel button rather, in SAP, it'll be encrypted. The other work that they've recently started to do and made some great progress is around CAD/CAM and PLM. So they can protect design drawings using the Microsoft Information Protection SDK so that your CAD files and drawings and things can't be stolen. All right, so we'll switch gears a little bit, and we'll talk about the APIs and then maybe how you can use the SDK in your own applications. We'll start at the bottom. So the policy API is what exposes the labels to my application. It doesn't actually do anything. So what that will do is it connects to the Office Security and Compliance Center service. It pulls down all my labels that are available for my organization, and then it really is just a state engine. So it will take in some information about the current state of a document, and it will tell me what I should be doing with that document to label it successfully. So really it takes inputs about the file and about the label, and then tells my application what it should do. As the developer, it's up to me to actually implement those actions. If I don't, then nothing gets labeled. The protection API is closely related to our old RMS SDKs, where I could take in some string as plain text and get ciphertext output. So it's really handling all the encryption and decryption operations in the SDK. It exposes the rights the user has to a file, will tell me like what I'm supposed to do with it, and that's about it. The takeaway from the protection API is that it's up to you as the developer to enforce rights. If I write an application and the user only has view access to the file, it's my job to make sure they can't copy or take screenshots or anything along those lines. If I don't do that, then I'm not properly enforcing rights and I'm not playing well in the ecosystem. So somebody could come along and copy and paste from the app or take screenshots. And so it's really important to understand that the protection around MIP is only good as the application. So if the applications aren't meeting a high bar and actually enforcing those rights, then your data is at risk. And finally is the file API. So this is what we find most of our customer developers use. So our partners will use policy and protection API because they're writing a lot of applications like the ones you see at the bottom, like Office or Adobe or Microsoft Edge. And then up at the top, we've got the file API, which is used by our customers primarily, and then some of the partners you see at the top. And the file API primarily abstracts policy and protection APIs and wraps it up in some file parsers and does all the work for you. So instead of having to provide buffers and download the policy and parse out some actions and things, we just say, hey, here's a file and here's a label ID. Go do your thing. And then the SDK will write that file out to disk for us or wherever we want to write it to. We have good support for a set of files like Office documents, PDFs, and then some of you may be familiar with our P-file story, which is that we've got things like text files and image files that we would wrap up in what we call a P-text or a PJPG. Those things are only viewable in a supported viewer, and I'll show you a P-text notepad type viewer here in a few minutes. But the application has to be enlightened and understand those things and enforce rights, and so I can't just open up a P-text in Notepad. I have to use the AIP viewer for that today. Just like for a protected PDF file, I have to use Adobe Reader or Microsoft Edge. For files that aren't supported, like if you were to take a CAD file, like a DWG, the output for that would just be what we call an actual P file. So instead of getting like a P text or a PJPG, the file output would be .dwg.p file. So we literally just tack P file in the end, and it becomes more or less an encrypted zip file. All right. So file API and use cases. So these are just some of the common use cases that we see for the file API. I'll demonstrate one that's in this bucket here in a few minutes. But the idea is that we support the well-known file types I talked about. We have the generic P file support. We primarily see this used for service applications where I'm scanning files across the network. So a great example would be like DLP. So files in transit, or CASB, where I'm detecting a file upload somewhere, and I need to reason over the contents of that file to make a decision about what I should do with it. So I would use the file API to decrypt that, inspect it, and then make a decision on whether I should allow it to be written or emailed or whatever I want to do with it. The other common use case is that we would use the file API to actually apply the label. So I would reason over the plain text content and then say, oh, wow, this needs to be encrypted because it contains 100 social security numbers. And then we could use the file API to apply the label to that file or email and then allow it to go wherever it was going. To some extent, it's used in interactive applications. We've seen some, not really Adobe Reader, there's actually another PDF reader that's using our file API to write PDFs in and out. So you could write an interactive, like user-based application that uses the file API as well. And then our CAD CAM partners are also starting to look at the file API for protecting CAD files. Protection API is pretty straightforward. I have plain text that I need to encrypt, or I have ciphertext that I need to decrypt. We enforce rights in the application, so if the application doesn't parse out the rights that I should or shouldn't have to this item that I'm decrypting, then I'll be able to do whatever I want with it. So again, it's important to enforce rights in your applications. Primarily used by security software that's inspecting files in transit, so I take the publishing license, which we'll talk about here in a few minutes, and I take the ciphertext, decrypt it, streaming, and then I'm able to inspect that and take some action. We'll also see this used by file format owners. So if we look at Office or Adobe Acrobat or other applications that are authoring, they need to use the protection API because they're actually handling all that encryption and decryption on their own rather than abstracting it to the file API. And I'll show you that here in a sample in a few minutes. And finally, the policy API. So we use that, again, to fetch labels and to compute actions about those labels. And so my application will take in things like the current label state, the current metadata, who's labeling it, how they're labeling it, and then information about the desired state. So what label am I trying to apply to it? What's the data classification? And then it's going to give me some set of actions that I should take. So some of those actions might be add watermark, add header, add footer, add protection, remove metadata, things like that. And then it's up to me to instrument those things in my application. We again see this used primarily by applications that are going to have some user interface where I apply a label or some automation where I apply a label. So they need to understand what the policy looks like and then use that policy to apply the label. All right, so I'll switch over to the first demo. Maybe. Okay. So this is an MVC application, ASP.NET app that simulates a line of business application, and it looks just like one, where I would upload some files and I need to apply a label. Now there's two use cases I'll demonstrate here. One of them is that maybe I'm concerned about protecting the information before it's written to storage. So this could be writing to a blob store, it could be writing to a file server, it could be writing to a temp folder in the case of my laptop. But I want to make sure that as the file's written, it's protected so that if somebody gets access to that information, they can't do anything with it. Or that only authorized people can do something with it. So we've got this add page, and if I click over to that, you'll see that there's two options. Maybe. There we go. So I've got an option to set a label on upload, or I've got an option to label on download. And so the first thing we'll do is set a label on upload so that I can make this highly confidential trade secret. And we'll save that change. And go over to our uploads. And I'll just drag and drop a PDF file here. And it tells me right here that this is going to apply a label called highly confidential trade secret. And so we've uploaded the file, and now I can jump over to download it. And I'll copy this link, and we'll start in Chrome. So I try to open this up in Chrome, and I get our what we call page 0 experience, which is telling me, hey, you need an enlightened browser or application to open this, which is great. This is what we want. We want to make sure that people are using applications that understand how to decrypt things and do so appropriately. So now I jump back to Edge. We recently announced support in Edge Anaheim, the new Chromium-based version of Edge that's shipping soon, or going to be stable branch soon. Based version of Edge that's shipping soon, or going to be stable branch soon. And they support protected PDF. So now in Edge, I can just click on this, and if the user is authorized, I'll actually be able to decrypt and view this message. And so you can see here that we know the file is protected by Microsoft Information Protection. I can click View Permissions, and I'll see the rights that I have. So they've grayed out print. I can save a copy of it, but it doesn't really do me any good because it's saving a copy of the same document. I can't edit or do anything like that. And so just by uploading that plain text file, we use the file API to apply the protection. Applying the protection is pretty simple, and I'm going to try to share this. I apologize if it's hard to read in the back. Just yell, and I'll make it bigger. So to actually apply the protection, it's pretty straightforward. We just have this save file option. So I've uploaded the file. We're going to ignore all the internals of like how the file got uploaded. But at the end of the day, what I get is an upload of some files, and I call this save file thing. And it's pretty standard. I'm just streaming a file to disk. But in between, I call the SDK. So instead of just writing the file directly to disk, I write the file to some APIs within the SDK, and then that passes it to disk. And so what ends up happening as I stream through the SDK, it applies the label to this stream here and labels the file for us. So we're able to, before it's written to disk, before anybody can get access to it, we actually label it in memory, write it out to disk, and the only thing anybody has access to is a protected file. And we'll come back in a few minutes and talk more about some of the internals and how some of this gets set up. Now, the other direction that I can go with this is to label and download. So let's say that same file that I've protected, I want to ensure that if an authorized user comes along and downloads the file, that they get a public label. And so now what I'll do is on upload, I say it's highly confidential trade secret, ensuring that it's protected while it's in the database or while it's on the file share. And I'll say, all right, if the user's authorized, and if I click the right thing here, if the user's authorized, then relabel it as public because we want to make sure that all the users can consume it. And so now if I go download that same file, it tells me that on download we'll apply a label called public. And if I open this up, it will be a plain text PDF. And so we've actually decrypted it at runtime before sending it down to the user. And these sample applications I'll have published hopefully early next week sometime on GitHub. All right, so now we'll switch and talk about some of the functional concepts. These are the key classes in the SDK, so these are the things that are really important to understand as you're building in functionality. Some of these things translate really well into file-based applications like a file handler, but all of these concepts apply to all three APIs. So you'll see we have a protection profile, a protection engine, we have a policy profile, a policy engine, and a file profile and file engine. But the first thing that we need to do is set up MIP context. So we do this once per application, once per process. And this defines things like my application info, like my client ID, my app name, my app version. Defines any override that I want to do for logging or telemetry, so I can implement my own telemetry settings or my own logging delegate, and I can define those here. And then it's responsible for unloading and loading the SDK library. So you run this one time, all the things get loaded, and then everybody's happy. If you unload it, and you still need to use the SDK, things will not be happy, and your app will probably crash. So we create one MIP context when we start the application, and then we pass that into the profile. So that defines some settings. We used to have this broken out where MIP context didn't exist, and we set all this in the profile, but we made it a little more efficient. And so the profile is the root class for any SDK-related operations not related to just setup. And so the profile is going to store or use the MIP context. It's going to define the cache storage. We have 3 types of cache storage: in memory, on disk, or on disk encrypted. We're going to set information about our authentication pattern, or authentication delegate and our consent delegate. And then if it's C++, we'll define things around any of our observers for async patterns. General best practice is to create a single profile per application. So again, 1 MIP context and 1 profile, and then from that point on, I'll add engines and handlers to that single profile. And so here you can see an example from C# of creating the MIP context with some settings. I create the profile settings object, which defines the context, the cache storage type, auth delegate, and consent delegate. And then I pass that all into the MIP static load file profile async. And then that just loads the profile, and then the rest of my operations happen using that profile. So the operation that would happen after I've loaded the profile is to create an engine. So the way to think of an engine is that this is the identity-specific class in the SDK. Anything that I'm doing as a specific principal or a user happens with its own engine. So if I'm running a SaaS application that's operating as a service principal, I create 1 engine, because that service principal is going to do everything. If I'm doing a web application that's authenticating on behalf of the user, I might create many engines for every user that's connecting to my service. And so it's going to authenticate to the service as that user. It'll fetch labels and classification settings for that specific user. And then any handlers that it creates are going to act in the context of that user usually. And I'll talk more about that in a minute when we get to handlers. So again, the example here is that we have this common pattern where we create some file engine settings, just like the profile settings. We pass in any information that we need. So in this example, I've passed in just an identity. Optionally, you could pass in things like hard coding the protection endpoint. So if you're using Active Directory Rights Management Service, ADRMS, the on-prem version, you could hard code that here, and we would find your ADRMS instance. And then there's a few other settings I can set there. So then again, just like the adding profile, I add an engine and say file profile, because I add engines to the profile, and add engine async, and then it loads and I get an engine for that user. This is the point where you'll see authentication happen. As you're using the SDK, you won't see any authentication happen until you load the engine for the user. That's when you'll get the ADAL prompt, or that's where you'll see your auth delegate fire. And the last really important class is the handler. And so across all 3 API sets, we have file handler, policy handler, and protection handler. And these are what actually do things in the SDK. So the file handler allows me to operate on files. I create a reference to a file or a stream, tell it what I want to do, and then the file handler takes care of it for me. The policy handler, again, does all the computation on which actions I should take in my application. So pass in some state or execution state information, and then it gives me results. And then finally, the protection handler is just taking in buffers and giving me encrypted or decrypted bytes. I add the handler to the engine. So you can see in the first line here that I've created an engine, and then in the next one we're saying that file handler is from file engine.create file handler async, and then I pass in the stream, I pass in the file name that I want to use for auditing. I can't remember what the true is there. So this will create the handler for us, and now we can operate in that file and do some things. All right, authentication in MIP SDK. So this is probably the thing that I spend the most time on when I have issues with customers or partners that are having trouble with the SDK. The SDK doesn't implement any authentication. We don't do anything. We leave it up to you to implement whatever class you want to use or whatever library you want to use to do auth. And so the C# applications that I have published out on GitHub will use ADAL primarily. You could use MSOL as well, or you could use any third-party library you want. Essentially what happens is there's this function called acquire token or acquire OAuth2 token. Acquire token is in C#, acquire OAuth2 token is in C++. When my application gets a 401 challenge from either of the services that we use, so we use the Office 365 Security and Compliance Center service, the MIP Sync service, for policy, and we use the, it's called AADRM in code, but the rights management service to do protection operations. Once I try to connect to that service, I'll get a 401 challenge, and that's when you'll see this fire in the SDK. So what'll happen is the SDK says, I have a 401 challenge. Here's the authority that I need that the challenge has. Here's the resource that I'm trying to use. And then recently we added support for claims. And so if that particular label requires specific claims, we'll pass that back as well. And then we don't care what you do with it. It's up to you. In all the sample apps, we'll use ADAL. And so you'll see here, we create an authentication context. I won't get too far into ADAL here, but and then I just acquire a token using the information that was passed into the method by the SDK. This works pretty well. The samples are pretty straightforward. It's just take what's there and then use it. We've seen issues where people are trying to hard code things and then they hard code the resource, and that's not going to work because as soon as I use the policy endpoint, if I hard code the AADRM endpoint, then I'm going to get an exception. So we'll step through this when I do one of the samples here in a couple minutes. So the storage cache. This was a big one because we had complaints from customers that were justified that my users can browse the file system and they can find the policy file and they can see what's in my policy file. And what's worse is that they might be able to edit the policy file. And so if a user doesn't like the fact that they have to label things and they know SQLite well enough, they can go and modify that file, put it back on disk, and nobody knows. So in version 1.3, we shipped support for encrypting the cache. And so we're using OS-specific APIs to encrypt that. So in Windows, it's like a CNG API. We use Keychain on Mac. I can't remember what we use on Linux. But we'll use AES encryption to protect everything in the database. So if you open it up, you'll just see garbage. And then at runtime in memory, we decrypt that. All right. So I'll switch gears and get into the internals a little bit because this will be important as we start to talk about how the protection API works. So a protected document in most cases is some document that we've encrypted part of it or all of it, and we have a publishing license. And a publishing license, it describes everything about that document as far as the rights management is concerned. And so we'll talk about publishing license more in a minute. Effectively, when I want to protect a file, I have to take all the stuff I care about and encrypt those things. And then I have to write some header that contains the information that I need to decrypt it. So Office has their own way of handling that as part of the specification. If we look at the P file format, what we'll see is something like this. And so if I take a text file, we'll create this P file header that's got information about like the version and then the clear text header that you'll see that tells you exactly what or how to use the file. We'll get the publisher details on like the offset, so we have to store all this information about where all these things begin inside the file. And then we store the publishing license and metadata. The metadata is stored using Adobe XMP, and it's all plain text. So that's true for no matter what file we have. We use XMP for that metadata. That's not true. Office doesn't use XMP, but for any other format, we use XMP. And then after we've written that, we take and just write the ciphertext. So take all the bytes from the file and then write them as ciphertext back to the file. And the publishing license is important because as you consume content, you have to, or create and consume content, you have to store the publishing license somewhere that it can be read later on. And then you need to pass it into the API when you want to consume so that the service knows what to do with it. The publishing license contains details like the template that was used to protect the content. It contains details about the service that was used, the tenant that owns it, the service key that protected it, so the public key that protected it will be in that publishing license. If it's an ad hoc definition where I've not used a template, but I've set specific user permissions, then that information will be stored in there as well. Interesting limitation about the service, you can only store about 200, or 400 rather, individual users in a publishing license ad hoc. Because as you add more rights, that publishing license grows, and we have a hard 2 meg limit for the publishing license. So if I go beyond that, the service will reject it. And that's to protect our service and your users. If I have a mobile device and I need to consume something and it's got a 10 megabyte publishing license for a 10K file, that doesn't really work well, especially on metered connections. So then I'll take that publishing license, parse it from my file, and then I provide it during consumption operations to create file and protection handlers. And so the file API abstracts this. I don't have to worry about it. If I'm using the protection APIs, I'll have to know how to use that publishing license. And I'll show you that in a demo here shortly. Or right now. Okay. So this application is a Notepad-like application that has classification built in that uses the MIP SDK to decrypt text files. And so, is that blinking? Okay. So what I can do is drag in a P file. So you'll see that I've got this protected text file on my desktop here. If I double-click this, it'll open by default in the Azure Information Protection Viewer. And some identity has set rights. I don't have rights to this. This is supposed to happen because this is protected with the test tenant. I tried to open it with my Microsoft account, and I don't have rights. So I get the access denied message. Now, I'm signed into this application using that demo account. So what I can do is just drag and drop here. And it's going to tell me this is some demo text. So, oops, my screen is flashing. OK. So what happened here is I actually, as soon as I dragged and dropped that, I opened up the file. I parsed out all the bytes related to the header that I showed you on that other slide, passed the ciphertext into the API with the publishing license, and I got the plain text back out of it. Additionally, we read the metadata from the document. And so you can see here that as soon as I opened it, it told me that the label is highly confidential trade secret. So if I want to make some changes to this and maybe relabel it, I can call this confidential external sharing approved. The label changes, and then I'll save it. And if we close that now, I should be able to open that with my Microsoft identity. And so this rendered in the AIP viewer. Now behind the scenes, and again, this will be on GitHub. It's kind of a lot to absorb now, but we'll publish this in the next week or so. Behind the scenes, I had to do a whole bunch more work. And so if I look actually at what I needed to do versus the file API, and this is really why we see file format owners and ISVs that take this API and use it, is that I had to do this p-file header reader where I'm literally just reading all the bytes from the file. And so I had to store things like the version that I had to read a few bytes and then translate that into a value. And then I read this clear text header. And I really have to understand the file format very well. And so if you're doing any custom work in your organization with like a proprietary file format you own, or you're a partner who owns like CAD files or something along those lines, this is what you would use. You would parse that file out on your own. And then when it comes time to decrypt it, you would pass that into the protection API somewhere in here. No, wrong one. Yeah, here we go. So I have this decrypt bytes function. Again, I need to pass in the publishing license. So I read the publishing license from the file. I pass it into the API with some streams and some information about the content length. And then it's just like any buffer. I run through it till it's over, or till we get to the end, passing in those encrypted bytes and getting the decrypted bytes out. All right, so I'll show you here now in the other application what this setup and everything looks like kind of end to end. Stop this. OK, so there's a whole bunch of breakpoints that I've set here, so we should hit all of them. Maybe. So I'm going to upload. You hit the first one. So as my application is initialized, the first thing I need to do is create the MIP context. And MIP context requires app info. App info is really important. If you're an ISV or you're doing work for your own custom application internally, and you're using things like AIP analytics, this is what's going to surface that information into that analytics, so you'll actually know which app is using it. So generally what we do is we set the client ID to be the same as your Azure Active Directory client ID or app ID. And that's important because then in the logs we can match those things up, and if I see something's being malicious, I can disable that client ID if I need to. You can put any GUID in there that you want. If it's null, we're going to throw an exception, so it has to be a well-formed GUID, but we recommend using the one from Azure Active Directory. App name and app version are what's going to surface in those events. So this is Tom's super duper Ignite demo app, and I'm going to see that in my analytics. And then the version. So then the next thing we'll do is initialize our auth delegate. We will set the path. So this is specific to web applications. We can initialize and we can tell the SDK exactly where to look for the binaries for the SDK. For normal WPF applications and things, this isn't important because all the DLLs live in the same directory. For a web application that could be x86 or x64, we send all the binaries up to the server, and then we have to tell the SDK, depending on the app type or architecture, where to look for those. And so we call this mip.initialize. We say we're using the file API, and then we pass in that path above. And so first, now, we'll create the file profile. We created MIP context, we've initialized, and now we'll create the file profile. And so we call create MIP context. We pass in some of that info that we've already created to initialize that context. We define our profile settings, and so these are my file profile settings specifically that define the MIP context, the type of cache storage that I'm going to use, our auth delegate and consent delegate implementation. The consent delegate implementation, we'll jump to that really quick because it's somewhat important. This is how we allow you to implement your own consent in your application. And so in a lot of regions, it's important to have the user consent to going somewhere where they will be tracked. The moment that I consume a document using AIP, I'm going to show up in logs. So my identity will show up in those logs. And so if I'm consuming outside of my tenant, I need to give somebody the ability to consent and say, yeah, I agree to have my information logged. If they don't consent, then your app stops. And if they do consent, then you log their info, and then they can consume the information. And so we're not logging anything crazy, literally just the email address that was used to consume the information. But that's up to you. So I've done something super simple and just said, always consent, like don't even ask. But here you could have a page pop up, you could have a command line interface, whatever you want. It's completely customizable. And then we'll load the profile. So the profile is loaded, and now the next thing to do is to create the file engine. And this is where we'll see authentication happen. And so as I step into this, we'll create an identity, which I've hard-coded here just to be service@miltor.com, which is my test tenant. We'll pass that identity into the engine settings and then create it. And now if we step into this, now we've seen what happens here where acquire token fires. So the SDK says, hey, I tried to authenticate to a service. I got a 401 challenge. I need to get a token. And so if we mouse over some of these things, we'll see that I got an identity, which was the one that I provided to the engine settings. We'll see that the authority comes in, so the SDK parses that from the 401 challenge and says, oh, I need to go to login.windows.net. We'll get the resource, which will be the policy endpoint, and then any claims that I need, which should be empty, because I don't need any claims. Now, this particular application is using service principal auth, and this is probably out of scope a little bit, but we can't use the common endpoint if we're using app key or certificate, so I have to explicitly tell it to use my tenant endpoint, and so I append my tenant name to the authority URL. And then now, it keeps jumping around because it's all async. And now what I'll do is create a client credential using that client secret, and then acquire a token. And then the API literally just returns, shoot, now it's all jumping around. There we go. Just returns a token. So this is just regular old OAuth token, and that's all the SDK needs. We'll provide that back to the service, and then I'll be authenticated, hopefully. So that was it. That was the setup. We created the MIP context. We created a profile. And then we created the engine, which triggered the authentication. So now if I were to upload a file, hit the breakpoint again. So I've uploaded the file, and I need to label it. So the upload triggers this apply file or apply label eventually, and we've got a memory stream that we're passing in. We're going to write the results to some output stream. We need to provide a file name, and this file name is used for analytics, and so for AIP analytics. So if you've deployed that and you want to see what your applications are doing or what files they're touching, you would need to provide a file name here so you have that information. We're going to provide the label ID that we want to apply and a justification message if required. So justification is required if I downgrade the label on some information. My policy might dictate that I need to justify why did I do that, and I could provide that here. So we'll jump down here. So now what happens is I'll create a handler. And so I've got another function that does that. We've kind of already looked at that, so I'll skip ahead. But we'll create a file handler using that stream and that file name. And we'll set some labeling options. And so here I need to define, all right, well, what am I doing to this file? So in this case, I'm saying that downgrade is justified, that my application or my user have said, yes, I really want to do this. We'll provide a justification message here in the labeling options, an assignment method, and then any extended properties. So I could, using extended properties, if I had custom metadata I want to apply with that label, I could set that here. And then finally, we'll call handler.setLabel, and we'll pass in that label. We'll pass in the labeling options, and then pass in protection settings. I mentioned earlier that we did some work around optimizing delegation and performance. We moved all the delegation stuff into the protection settings. And so what I could do here if I wanted to change the user I want to label on behalf of is specify a delegated email address in protection settings, and we would write that for that specific user. In the past, we did that as part of the engine, so every time I had to delegate as a different user, I had to start a new engine, which meant I had to auth, which was a whole bunch of round trips to the service. So to save on performance, to help the AIP scanner, we moved this into the handler, and so now it's much more performant than it was in the past. And so setting the label isn't the end. There's one last step that I have to take, and that's actually to commit actions. And so you'll see here that there's this commit async call. So if I run this next step, nothing actually happens. So we get to set label. And if I continue on, the file isn't actually written with the label on it until I call commit async. At that point, the file's written, all of our audit pipeline will get notified, and then we've successfully, well, that's not true. Part of the audit pipeline gets notified, and then when I want to actually notify that, hey, I did something here, I'll call this notify commit successful. And then at that point, the service will write the audit event, and we'll see that show up in our audit logs. And so then the file is uploaded. All right, so last few slides here. So MIP labeling on graph, we talked about this briefly. You can use this today. The documents are all published. The endpoint's here on the screen. It's just it's the beta endpoint. Information protection / policy / labels will get you started. That will pull your label down, for your label policy down for the specific user. And then we've exposed a few other APIs to allow you to evaluate label application, evaluate label removal. And again, that doesn't actually do anything. Your application has to take those actions and implement them, but we will expose them through a REST interface. This was a pretty common request from some of our ISV partners who don't want to either integrate the SDK because it's some overhead for them, or they're using languages like Java or Scala that we don't yet support. We talked about this briefly, but custom integration. We're seeing a lot of need for mail decryption for long-term archiving. So we have a lot of financial customers that say, I have to archive everything that ever gets sent through my system, and it needs to be in plain text. And so they'll decrypt it and send it off to be journaled somewhere. We're seeing common requests for mail and document decryption for DLP inspection. I've been impressed by a lot of our customers because they've been taking, and some of them even writing C++ code, which most had an allergic reaction to for quite a while, where they're filling gaps in their DLP vendor story. And so they're writing this code to do the decryption of mail and documents because their DLP vendor can't. And then they pass that off to their vendor and then get some result and take some action. And then we're seeing a lot of interest around PDFs, so encrypting PDFs as part of line of business applications. Looking ahead, so this is what we're going to work on, or are working on this quarter. We'll ship this hopefully in January, or the beginning of it in January. We've started work for Java support. So we'll support Java on Windows and I think Ubuntu and Android to start with. And then we'll carry into the other platforms as time goes on. That's been probably our #1 feature request as far as language support. We're working on dynamic content marking, and so the ability to provide variables and things in AIP today is a common request so that my content marking will show things like the username or the date it was labeled or things like that. And then finally, pre-licensing support. So when I download something or I get the first copy of a protected file or email, we will fetch a license right away so that the user doesn't have to make a call later. So we'll pre-license that for them. And those are all things that we're working on this quarter that will hopefully ship around January. Links and resources. We had a theater session that talked to some of our partners this week. That was THR2098. All of these links you see here are links that our team maintains as far as samples, docs, binaries, and our blog. So if you want to get started to hit those. We also have our Yammer community, which has about 3,000 customers involved worldwide, which is yammer.com/askipteam. And if you sign up there, you can reach any of us on the PM team for help and questions. We check it frequently. Did you get a picture of that? I can go back. Cool. All right, well, thanks for your time. We are out of time. I'll be here for a little while to take questions. Please fill out your evals. We take them seriously. If you have any great feedback or terrible feedback for me, I'd love to hear it in person, but please leave it in the comments. Yeah, we take the demo or the session evals pretty seriously. So thanks for your time. Hope everybody has a safe trip home today or tomorrow or fun at Disney.